this session is about the technology of self-driving cars and how that's really going to play out over the next few years here. So we're going to do a quick introduction of the panel. We've got Ravi from Savari, who's doing kind of vehicle-to-vehicle or vehicle-to-something communication. Modar from Iris, which is using a lot of AI for discerning information about people. And Lue from Quanergy, which is one of the premier LiDAR companies. So we'll start with just very quick introductions, and then we'll switch into the questions and the topics. So Ravi, if you'd like to just give a quick bio.
Hi. I'm Ravi Puwala. I'm founder and CEO of Savari. We are a V2X sensor company focusing on vehicle-to-everything communications. As you know, that the penetration of Wi-Fi and cellular chipsets into cars is still about 25%. As we see that most of these modems are currently used for connectivity, and we are looking at repurposing them to do for active safety, mainly for crash avoidance and other applications.
Hello, everyone. My name is Modar Alawi. I'm a founder and CEO of Iris. We do deep learning-based in-cabin vision AI for driver and occupants monitoring. We go beyond face analytics to activity recognition and action recognition, et cetera. Been doing this for a couple of years, and we believe this would be critical for what's soon to be known as the third living space after homes and offices.
And I'm Louay Eldada. I'm the CEO and founder of Quanergy. We make solid-state LiDAR. We are the only company that makes completely solid-state. I'm not talking about micro-MEMS. Truly solid-state LiDAR that's high performance, very high resolution and accuracy, reliability. It's all silicon CMOS, no moving parts, and is really low cost. A couple of $100 in volume. It's still only several $100 if you buy a single unit. So we provide the most capable eyes, and we just heard about the brains and the communication, so we have a good mix here.
Okay, great. So maybe, Lue, I can start with you and just get your perspective on what does the next 3 or 4 years look like on the road, and how does all this technology, like there's a lot that is in labs on experiments, under special permit, but when we talk about actual consumers getting in cars, how do you think that looks over the next few years? And what's the first thing that happens? What's the first thing that matters?
Yeah, you can already get level 2 automation, which is advanced driver assist. In my opinion, the industry is going to skip level 3. It doesn't mean no one is going to do it, but generally. Level 3 means you're expected to react frequently. So if you take a nap, if you're texting, it's just not realistic to expect whoever is sitting in the driver's seat to react frequently. It could be a few times per minute. So the industry is going to go directly to level 4. And level 5 might take till 2025 or beyond. So level 4 is my short answer to the question. Level 4 is basically a level of automation where the car simply drives itself, but there is a driver in the driver's seat, and they will be expected very infrequently to react if there is an extremely unusual situation. That level makes sense, because level 5, which is truly driverless, where a vehicle without a human being in it comes to pick you up, it goes to park itself, it drops you off, and you can take a nap in the back. That's going to take a lot of development, especially on the software side. The brain has to be just almost as good as a human brain in terms of making decisions, making the right decisions. It can be fast, but it has to be right.
Okay, so for level 4 that you say is coming, is this, do we need new laws, or we're just doing it under driver assistance laws?
Well, level 4 does need laws, does need support, but not the same as level 5. It's easier to pass those laws because you do have a human being in the driver's seat. It's going to happen next year, 2018. We know exactly which car makers have those plans.
Okay. How about Ravi, Louis? What are your thoughts on this? How does the technology affect the road that we're all driving on over the next few years?
It's going to be affected very much, but I think the regulation is really the biggest hurdle here. I mean, we can speculate and say 2 or 3 years. Tesla sells today full autonomy, or whatever they consider to be level 4, I guess, or 3.5, but it's not there yet, right? You can buy the package and still not have it activated until regulations happen. I think it's going to take some time for all of this to be well understood, well documented. It's going to take a lot of mishaps before some regulations will occur much quicker than we expect. But there is no question that this is evolving, and level 3 will be here by the end of this year. Level 4, like Louis mentioned, is actually in production or slated for production for 2018. And a lot of others are expecting level 5 to be ready by 2020. I'm always very cautious about that because what makes it technologically possible doesn't necessarily make it a product. And so for it to be a product, it's an entire ecosystem with regulations, roads, insurance, and a whole lot of things.
All right. So Ravi, what do you think about the product? Like, what products will come to market?
The product is going to be more of a semi-autonomous car or a fully autonomous car that's going to be integrated into the system, right? I just wanted to add one more thing about the regulation framework. We have cameras and LiDARs, which are the remote sensors, but in order to achieve full autonomy, you have to have a cooperative nature between all the cars and the infrastructure. And this is one of the things that our company is focused on, is building this communication framework. And NHTSA has just passed a rule-making process to mandate every new car by 2023 should have a communication sensor integrated into it. And this is one of the things that V2X is all about, is to repurpose this spectrum that's been allocated to have cars to communicate with each other. And these sensors are very critical to kind of create the redundancy that's needed in the sensor fusion mechanism.
Okay, so I've got a question for I don't know whom, but like my feeling is that if you have really good level 2 autonomy, meaning it's just driver assistance, but it's superhuman driver assistance, for the consumer, let's say I buy a Model 3 next year or something, assuming the software progresses to where some people think it will, why do I really need anything more? Why do I need I can't go to sleep, I need to keep my hands, but don't I get just like 80% of the benefit from a car where I don't have to think about driving, I don't get into accidents, I don't have to worry about anything? Where's the value for the consumer? Is it really in level 5 or is it in level 2?
Level 2, some benefits that you do not get at all in level 2 are productivity. You're not supposed to be texting or emailing or doing anything at all. In terms of basically stress level in stop-and-go situations, you're still completely driving the car. Just it's giving you alarms when you drift out of the lane and such. So really the main benefits we talk about in terms of revolutionizing the future of the automotive industry are not realized at level 2.
Okay.
The best example is, in the Bay Area traffics, who would not like to have automatic braking, right? You're always going back to back on Highway 101 or 280. It really allows you to be able to, if you are distracted for a second, and having the car to be able to brake on your behalf is a huge benefit.
Yeah, I agree. I mean, level 2 has been around for a year or more, at least from the Tesla standpoint. Anybody that owns a Tesla knows exactly what they can expect from level 2. You're still tied to the drive-in task. You cannot multitask. You cannot do any of these things. And obviously, you want to have more time to do more things if you can have a machine do the drive-in for you. So any level higher than level 2 would be nice to have. A level 5 would be ideal, but obviously we're not there yet. So like Louis said, I think level 3 will somewhat be skipped. At least there is one manufacturer that's skipping it publicly. They talk about it all the time. But what most people are expecting or are probably excited about is level 4 because it's achievable. You still have to be behind the wheel, so it's not like that scary kind of moment. The car still has a steering wheel and a pedal or multiple pedals, but it does most of the driving for you. So it's the reverse of level 2 where you need to do most of the driving. And I think that's kind of when people refer to autonomous driving, that's really what they refer to, at least realistically, knowing when that will happen, from which vehicles, which manufacturers, where, which geography, etc. And I think it does make a whole lot of difference to have a vehicle with level 4 as opposed to level 2.
Okay, great. So let's switch tracks a little bit and talk about kind of the ecosystem here. As Professor X kind of outlined, you've got all sorts of things. You got sensor makers, you got car makers, you got software, and different flavors of software. Like, how does this play out? Is this going to end up being like more like an Apple Surface model where everything's integrated under one manufacturer, under one stack, even like same company, or is it more like Windows, Android, mix and match different solutions, and like, can both of those exist together? Can they compete against each other?
On the tier 2 level, so on the component manufacturing level, there will be multiple suppliers. On the tier 1 level, each tier 1 meaning automotive suppliers of the likes of the system integrators, basically Delphi, Bosch, Continental, they would provide a full system that includes all of the different sensors that come from different suppliers. I'm going to add that all types of sensors that we talk about, except the ultrasonic sensor, will, for the foreseeable future, all be used. It's not going to be LiDAR or camera or radar. It's going to be all three of those for the foreseeable future. It's just a matter of which does what.
Right, there's no doubt there will be a lot of consolidation as it is the case in every industry and as we've seen over the last couple of years, and obviously that's kind of what's sparking innovation and competition, et cetera. But there are some, the 4 horsemen or 5 horsemen in automotive tier 1 suppliers, the Bosch and Delphi and Denso and Conti. And these are the guys that actually almost decide what goes into the vehicle, or at least present with a lot of conviction what needs to go into the vehicle for which model. But there will be a lot of consolidation from the tier 2 level, from the suppliers to the tier 1 level. Those are other components manufacturers or software guys, etc. The model will not change dramatically from what it is today. There will always be OEMs. Maybe there will be some consolidation there. There are a lot of OEMs that have not announced any autonomous plans yet. Think about Mazda and think about some other ones. And so, either they're thinking about licensing something from one supplier or from one tier 1, and all of a sudden they have what they need because they already have distribution. Or maybe they're behind the wheel for reasons that we just don't know. But it will not be so much difference. There will be a little bit of consolidation, in my opinion, from the OEM standpoint. There will be new entrants. There will be the same tier 1s, probably very little consolidation there, but there will be a lot more consolidation from the tier 2 level.
And why do we need more than like 2 or 3 autonomous stack vendors? Like if you look at mobile OS or desktop OS or everything, like those seem to have always consolidated down to a very small handful.
Yeah.
But here we're going to have 9 different Google.
Eventually. Initially, there will be lots of redundancy. Each automaker will make bets on certain suppliers, and there is time to basically down-select the winners because you have redundancy. You don't have to immediately figure out which technology is the winner. But over time, yes, there will be down-selection, and there will be one or a few suppliers for each type.
I think it also goes back to what's the standard platform for some of this fusion integration, right? Today, NVIDIA and Intel are leading some of the sensor fusion architectures, and a lot of the stacks, a lot of the application modular platforms are going to be based on how these hardware architectures are going to evolve and whose stacks are going to be predominantly accepted around the industry.
Okay, one more question, and then we're going to do some audience questions. So, data, deep learning. Obviously, this is a big part of what everybody's touting as a key component in terms of the advancement of this. How important is the data? Is there a critical mass after which you kind of have enough and you don't need any more? Or does the one who just get the most gazillion miles end up being better? And how does data play out into the whole mix of things?
It usually is, there always is a sweet spot between quantity of data and quality of data and the software that actually makes use of that or sense of that data. I wouldn't say the companies that will prevail are the ones that are going to have the most data or have driven 1 billion miles, or that's just at some point just reaches ceiling from a technology standpoint. The variations of situations and scenarios could still be, with just 1 million miles as opposed to 1 billion miles if you want to incorporate all of these variations. Therefore, the quality of the data matters a lot.
But isn't that on one hand you're saying, oh, level 5 is going to take 20 years, and the other hand, oh, I only need 1 million miles to get everything down. Isn't the edge cases what you really need that much more data for?
Level 5 is not going to take 20 years primarily because of the lack of data. Self-driving cars is a solved problem today. Actually, it's being solved. It's a solved problem. It's the ecosystem around it that really needs a lot of additional inputs. The cognition, whether you will hit the pedestrian or just go off the cliff, and there's a lot of these things. It's not the fact that the car can drive on its own is what makes level 5 difficult. It's the actual cognition and everything around it from the ecosystem. I truly believe that data is great. It's the fuel for any software, but I don't necessarily agree with the idea that whoever has the most data basically will have the best performing software or technology at all.
I think if you go back and look at how much data is being generated by these autonomous cars every hour, I've seen some statistics which says 20 terabytes of data being generated every hour on these cars. So now the question comes down to, is the computation is going to happen on the car or on the cloud? So there's always going to be a trade-off between how much computation can be done inside the car versus the cloud. And I think this is where a lot of the data analysis in terms of what algorithms really function very well and doing a post-mortem in terms of what would be a better algorithm to replace some of these.
Okay.
Maybe I would add one thing that there's different schools of thought about collecting data and deep learning and having that be the fundamental approach to decision making. So some people believe in pushing that to an extreme level and just keep teaching the algorithms how to react based on trillions of images. Others believe that it's never going to be a deterministic approach, so it's a no-go, and you just have to do simultaneous localization and mapping SLAM and make decisions on the fly, as opposed to just be ready with all scenarios being figured out based on lots of data learning.
That's right. I think what Louis was mentioning is there is a difference between supervised learning, and that's what we're talking about with deep learning, and that's still limited. Once we reach unsupervised learning, yes, probably more data would matter more, but for now, it is supervised, and it can only learn what you can teach it and what it's labeled at and things like that. So there's still some limitation there in the AI, the core AI itself, and I think we're far away from unsupervised learning, where you have machines just learn as humans just by seeing things repetitively without necessarily knowing what these things are or reading what the labels are. And in that case, I believe more data would matter more.
All right, good. So let's go for some audience questions. And again, whoever has the mic, if you can please select someone there.
Just a request for everybody. So if you could see on the slides, you can ask questions via the Tycon app, and we would prefer that, so that we can ask more questions. And if people have similar questions, we can aggregate that and ask. And now I'm going to just pass the mic around for a couple of questions we can take now.
Hi, my name is Mohinder Sika with Sensital. So I have two-part question. First is, how do you stop the, let's say, kid, putting up a stop sign and fooling the network in the car? And the broader question is, because of those reasons, do you think the self-driving will actually happen more in constrained environments, such as in trucks and in closed areas like campuses rather than in public roads?
So, I mean, one of the use cases for self-driving nature, there's a company called Peloton, which started off with focusing on platooning. So 80% of the traffic, especially on interstate highways, is commercial trucks, right? And the notion of platooning is about making sure that the lead car can do the main driving, and the cars that are following it can follow on whatever the actions that the lead car is trying to do, right? They have shown significant use cases about how much fuel can be saved, how it can be efficient. So this is already being applied and been tried out in on interstate highways. So definitely it's going to be in a more controlled environment. First it starts with the commercial trucks, and also in some smart cities where they can kind of corridor off on how to set up the infrastructure to allow self-driving cars to work more cordially. Yeah.
Hi, I'm Rakesh Vaidyanathan. I have two quick questions. One is, what's your go-to-market model, which is, would you license your technology to, let's say, tier 1, tier 2 companies outside the United States in some cases? Second is, do you have a retrofit model where existing fleets, can they use your technologies, any of your technologies, to achieve a certain level of autonomous driving?
I think all of us here are set up as tier 2 suppliers because we provide our technology to be licensed and integrate with an automotive tier 1 like Delphi, Denso, and Bosch. When it comes to aftermarket technologies, it depends on the combination of the sensors being used to build an aftermarket system. You can build an aftermarket system with the combination of a camera, LiDAR, or any of the 3 sensors that are right here, right? So it goes back to what is the purpose of the aftermarket platform. Is it just doing the fleet management? Is it just doing the data collection? And the consumer-oriented aftermarket has a completely different purpose. But yes, it's more of a licensing and a tier integration.
My name is Amit, and my question is, so once the car reaches this level 5, what's the interface going to be like? Is the user just going to enter the destination and the car is going to take you there? Or once you're sitting in the car, can you tell the car, drive a little slower, my tummy is not feeling good, or drive a little faster, I'm in a hurry, or take a left turn here? Can it, will it respond to those kinds of?
Yeah, we see actually OEM to OEM differences in how they would like the vehicle to behave. As you can imagine, Tesla would typically make a different decision and might make more aggressive moves because that's your typical Tesla driver / passenger enjoys that. And a Mercedes S-Class owner might prefer a more luxurious and behavior that's not kind of as aggressive. But within each model, OEMs are talking about having the person who's controlling the vehicle, and we cannot call him the driver, right? The person who's controlling the vehicle decide the level of aggressiveness based on their personal preference.
I love driving. When I look at these self-driving cars, the most favorite command I would like to give is to go park yourself. I think that is the most frustrating part for a lot of us is to how do you, where do you find the parking? How do you tell the car to, park by itself? Yeah.
Yeah, I think you'll see, and by the time you get level 5, which is a ways out, like all of this is API driven, and you're going to have all sorts of app that decides what to do. A lot of it will be mobility services where you get in some car that's not your own, and depending on what service you're going to have, it's going to be different constraints and rules and what have you.
Yeah, I would add, the underlying question is, when you talk about the level 5 vehicle, is it a vehicle that you own? Is it a service vehicle that's from Uber or something similar? Is it a vehicle that's limited to a certain geography, for example? And the answer is all of the above, right? So it's going to have to be a hybrid between the two. You can either just call the vehicle from your phone and it picks you up and then takes you to where you need to be, or you can set up preferences and parameters on your own app, or even within a vehicle. If something comes up and you have an emergency and you need a vehicle to stop, and you can make a U-turn and go to where you need to be. So all of that will be available at the fingertip of the consumer, depending on which service they prefer or they will be using, whether they will own a vehicle, which vehicle manufacturer. So there will be, just like insurance, they all offer the same products, but they try to differentiate with just small things like accidents forgiveness and this and that. It's going to be the same thing. So some OEMs will probably market to you and say, hey, you can make up to 5 changes within the same trip if it's within 10 minutes. And some will say, no, we only take you from point A to point B, but then it's going to be a lot cheaper. You can't change your mind. All of that is logistics that are fairly easy to solve, I guess.
And speaking on mobility, do you think the current leaders in mobility will survive the transformation to autonomy? Is that like a big change, or is that like a simple thing for them?
It will be a transition to what it's known today, or will be known soon as the ridership economy. So it's not going to be, the autonomous vehicle industry, or it's just going to be a ridership economy. And it's not just going to be for vehicles alone. It's going to be for a whole, any autonomous machine or system, basically. And that's going to be a new economy where the average number of occupants will be higher, per vehicle will be higher than it is today. Obviously, you will see less congestion, more people per vehicle. There will be new services inside these autonomous vehicles, and it will be somewhat of a pivot, in my opinion, from the car sharing companies or any company actually that's operating in the mobility space today to kind of shift over to serving up that ridership economy. Because at the end of the day, once the vehicle is driving on its own and the roads and everything else is figured out, the insurance is figured out, then the focus is on the people and who is inside the vehicle. How to accommodate them, how to provide the best service, how to make sure they are comfortable, and how you can measure them, how you can make money out of them, and how you can offer services that are hyper-targeted based on who they are, what activity they're doing, what emotions, what gender, what age group. All of that good stuff. So in my opinion, everything soon, or as soon as we start figuring out what as soon as we have somewhat of a close idea about when level 5 will hit, everything will shift to what would be a ridership economy, in my opinion.
Yeah. So it sounds like there's no privacy issues there at all. But okay, next question.
Nishit Desai here. I'm a lawyer. We specialize on the regulatory side of autonomous vehicles, and we try to prepare ahead of time. I just want to question, is it likely that in about 10, 15 years or otherwise, the same car will not only go on the road, but also go in the skies, which we talk about flying cars, and also swim in the ocean? Today we have 3 different sets of legislations or regulations. One on the road, Vienna Convention on Transportation, on the air law, and also sea law. We need a convergence law now for the vehicles. And do you see that? I've heard a lot about flying cars, and we have studied a lot on that, and also autonomous, but not on the cars that swim. So same car can go in all 3 directions. Is there some movement on that as well?
There is. We see all of the above, and I would add underground roads, not just the surface roads. Yeah, there are a number of companies developing flying cars, whatever you want to call them. They call them drones that carry passengers, whatever you call them. It's a vehicle that carries you and is autonomous. That's going to happen. That's going to happen. We have customers in that space. We support them with our LiDARs. Yeah.
Talking about the swimming cars, right? Is
The
there
what?
any swimming cars?
Yeah. There will be a retrofitting. I think I get your question. There will be a lot of retrofitting, the same way Cruise started retrofitting regular cars into autonomous cars. There will be a retrofitting as well once those vehicles, where you can make multi-use or more than one use out of them. There will be a lot of retrofitting. That's actually what typically, that's generally the first trend that we see in most innovations, something that already exists. How can you make it better, or go into multiple places or drive autonomously before we can even spend a lot of money, R&D resources on making it an actual final product. So in my opinion, there will be a lot of retrofitting, and the laws will somewhat converge based on that retrofitting.
Cars and self-driving cars.
Sorry.
Smart cars. Why are we calling self-driving cars? They are becoming more smart cars now. Smart.
Well, smart is just a broad terminology, I think. Right, yeah.
All right, so I think we have time for maybe one or two more questions, and then we'll. All right, over here.
For a while. This is a question for Ravi. Ravi, you mentioned V2X. What can you say about the attention being paid to security? Because then, in terms of V2X, if it includes V2V, if there's any malware, danger to be, downloaded into the car, are you addressing that in your systems?
Sure. So today, all the communications that happen between the cars, we process the data and we provide warning mechanisms to the vehicle. Right? The only data that we write into the car is about the feedback mechanism that there's a potential collision, on the same lane, or when you're trying to change a lane. So a lot of the communications in the V2X domain is based on PKI. Every message has a security certificate that ensures that the authenticity of the origination of the message, right? The framework also has a security credential management server managed on the internet. So that's the one that is actually coordinating who is the bad actors, and how do we make sure that the cars that do not have the right certificates are repudiated. So this is not a mesh network that we are creating. We are not trying to become a gateway of any data that can be passed from one car to another car. This is more of a single hop mechanism where the data is processed, and it's only given as a feedback. We can do the actuation, but that's sort of the next stage when we go into level 4 and level 5. So today there's a lot of restriction in terms of what can be read and what can be written into the CAN bus. And most tier 1 suppliers have a secure CAN layer. So we are reading a lot of the data. We process the information coming from outside the car, but what we provide back to the vehicle is very limited. It's very restricted.
Okay, great. So we're going to wrap this one. Thank you very much, Ravi, Modar, Louis, and they'll all be in the back afterwards if anybody has questions to ask them. And then we're going to switch on to governmental and regulatory panel shortly. So thank you.
Thank
Thank you, Rahul.